Hey, welcome back. Today's challenge is really interesting, guys. So basically, I'm gonna be solving Jakarta with you. So don't forget to try to solve it on your own before you watch the video. Don't forget to follow me also on Twitter, and don't forget also to subscribe. So yes, let's not waste too much time. Let's start the challenge. So what do we have? So overview. So if firmware update further rejects password which are too long. This log is attached to the log ID Pro Hardware Security Module 1. Okay, interesting. So if we try to run the program on the card, so what do we have? So it's the same challenge or the same perspective as the Santa Cruz challenge, which is the previous challenge that we have solved. So I gotta give the username. So let's, for example, send item byte. I have to uncheck that. Um, let's give item byte 123, and we have the CPU have been stopping from running. The program is no longer running, and we have password is not correct. Okay, this is interesting. So if we try to reverse engineer the code statically and try to understand what this program is doing exactly. So what do we have? So let's search for the main. So this is the main. So what do we have? So it's adding this negative value or this value to the stack pointer, then is calling the log in. Um, the same pattern as the previous challenges, and we have a clear register 15. Okay. We have also an unlock door. Okay. I think we gotta use that for sure. And we have a test username and password wallet that the hardware security module 1 would use. And what else? So this is the login function. Okay, so we are going to be pushing the register 11, and then getting this stack pointer aligned with this offset, and then we just print the casual messages that we have been seeing on the microcorruption challenges, which are just the username and the password and all of that. So we start by reading the username. So we are going to be reading 0xFF, which is 256 um, bytes of data, bytes of data. Um, then we obviously read the username, and this is the destination address. What else? Then after we read the username, we just print it. So we print the username. So one thing to mention here, guys, is that we have this address as the address of the destination. So basically, we're going to be reading the username into this address. Okay. So once we do that, this pattern is pretty obvious. We have seen that in the previous challenge. Also, it's just a simple loop. So basically, we move the address 2401 into the register 15. So this is register 15 equals to the 0x2401, and then we increment the register 15, and then we test we basically just test uh, if the register 15 or the address at the register 15 is equal to 0. If it is equal to 0, then we stop, otherwise we jump if it's not equal to 0 to this increment back again. So we basically keep incrementing the register 15 until we hit a 0, which means that this one or this block of code is gonna be just doing a simple length calculation. Yes. So once we calculate that length, we basically move the result to the register 11. So register 11 equals to the register 15, and we subtract the beginning of the string, which is the username, the beginning of the username, which is loaded in 2402. We subtract that value from the register 11. So basically, register 11 is going to be register 11 minus 0x2402, and we move actually also um, the address 0x2402, which is the beginning of the username, into the register 14, I'm sorry, just to prepare str copy call. Okay, so and we move also the destination. So this is basically the source, which is equal to that, and the destination equal to the register 15, which is basically in the stack. So we basically gonna be copying the username into the stack, and then we copy the username to stack. Yes, and in the register 11, we basically have length of username. Yes, so this is the length of the username. After that, we basically try to just compare the length of the username. We basically try to compare the length of the username with the 0x21. So it has to be, so jump if there is no carry. So we jump if there is no carry to this address, which is this one. Um, Otherwise, we're gonna be going into the invalid password block. So basically, this address should be the address of the invalid password. Something that we can check that if we want. So basically, it's 24. 24. So we need to move the address that is at this address. So this instruction is going to be saying like go and check what this address is having and move exactly that value as an address. So for example, we have to check what 24 is having. So this address. So when we add the AND, he's basically going to be interpreting that as an address and going to be flipping the order of the bytes since it is in Little Indian. So it's going to be 4638. So if you check 4638, 38 is basically here, I'm sure. Nope. Yeah, it's here. So this is basically 4638, which is invalid last password too long. Yes. So this is basically just printing invalid password. Um, yeah. So if the length of the username is inferior to the 0x21, then we're gonna be jumping if there is no carry to this address, which is this one. Otherwise, we will be doing this. So we have to verify that this condition is true. So this condition should be true in order to just pass down to the password. Okay, so this is basically invalid username, not um, not just simply the password, but I suppose when they implemented that, they check before they check it with the username than with the password. Yes. So basically, they just print out the same message for the username and the password. So anyway, just putting invalid message in general. So what do we have? So once we check if the username is cool and the length of the username is inferior to the 0x21, which is 33, I suppose. Let me just do a little check. Yeah, it's 33. Yeah. Once the length of the username is inferior to 33, then everything is cool, I think. So what do we have? So please enter your password. Now we pass down to the second stage, which is reading the password. So we basically move 0x1f into a register 15 or 14, I'm sorry, and then we subtract the old length we subtract the length of the username from the register 14. So and then we basically end it with this value, and then we move the destination address, and then we read. So the trick here is that he's gonna be subtracting, so 0x1f, so register 14 is going to be having 0x1f minus the length of the username, and then register 14 is going to be equal to register 14 and 0x1ff. Now the thing is, if this value is bigger than 0x1f, then the value would turn into a negative value. And then once we end that negative value with the 0x1ff, it's gonna be turning into 0x1ff. Why? Simply, if let's just try, for example, setting the length of the username as the maximum value that could be. For example, since we are comparing the length of the username with the 0x21 and it should be inferior to the 0x21, let's try, for example, to send him a length of a username equals to 0x20. So 0x1f minus 0x20 is basically minus 1, and minus 1 in hexadecimal is just 0xfff. If I'm not wrong, is this gonna be 1ff? Um, nope, it's gonna be exactly, let me just try to use hex to decimal, or decimal to hex. So if we try to do that, um, okay, mm, it's taking too much time to load. Okay, anyway, if we just do that, let's for example just use the minus 1. So if we use the minus 1, so if we try to, for example, just do minus 1, and we try to end it with um, 0x1ff, and we try to get, for example, the hex of that, we basically get 0x1ff, which means that now when we try, for example, to read the password, we have the ability to read 0x1ff. So if we try, for example, the other boundary, if we send, for example, for the username, if you send the username with a length equal to 0x1f, which is equal to 31 bytes, then for the password we will be able to just read 0 bytes, so we won't be able to read anything basically, because 0x1f minus 0x1f is obviously 0. So this is a vulnerability in the code. The developers who updated that firmware is basically having an issue there, because if you can read 0x20, you obviously land on that problem, which is that the password now could be 0x1ff, which should be opening some attack vectors, I suppose, that we can exploit. Yes, so this is reading the password. So those are some just of the insights that can came into your mind when reading such a thing, especially this part. So once we do that, we just print the password again. So we print the password. So once we print the password, we copy the password to the stack. Once we do that, we move 0x21. So this is the same block. So basically this block just calculating the length of the password. Yes, so once we calculate the length of the password, so we subtract, so register 15 is gonna be having length of length of the password, yeah. And then once we calculate the length of the password, so we basically add the register 11, which is having the length of the username, with the length of the password, and then we compare them. We compare just actually 1 byte with the 0x21, and if the result is if there is some carry, so we jump if there is no carry to this part, which is gonna be trying to check if the username and the password are valid or not. Otherwise, it's gonna be just stopping the program execution, which means that, so this is basically summing, or the sum of the length password plus the length of the username. So we should be just flipping the order. So yeah, so this is the length of the username and the length of the password. Register 11 is having the length of the username. Register 15 is having the length of the password. Now, there is a little vulnerability in here. So, for example, there is this little thing. If you basically try to compare, let's suppose register 11 is gonna be having 0x1f. So if you try to compare 0x1f with 0x21, then 0x21 is bigger than 0x1f. But if it's for example, let's say having 0x22. So if you compare 0x22 with 0x21, then obviously 0x22 is bigger. But if we try, for example, to send 0x21f, let's suppose the register 15 is gonna be having 0x21f. Then if we try to compare the byte 0x21 with the 0x21f, then this is obviously bigger. Why? Simply because when you try to compare the value, let's say in this case a byte, which is 21, with the content of the register 15, then it's obviously going to be taking the lower bytes and comparing the lower bytes of the register 15 with the 21. So in this case, it's going to be taking the 1F and comparing it with the 21, which is really interesting. Now, just taking that into consideration, we can now try to exploit that. To exploit that, we can, for example, just try, for example, to send. Um, the first thing to do is to make ourselves can read 0x1ff bytes of data for the password. We have to first exploit the first vulnerability, which is the -1. So the -1. So to create the -1 that we have talked about and change the amount of data that we can read for the password, we should first send 0x20 data for the username. This is the first step. Second step, so basically the first step. So and the second step, since we will be having since we will be having the ability to read 0x1ff of data, so we will be reading that 0x1ff of data for the password. So the sum of these two is obviously going to be 0x. Let's say it's going to be 0x how much data we're going to be having. So 0x20 plus 0x1ff. So if we hexify that, we have 0x2f 21f. So basically this value is going to be bypassing the checks. So we can override, so that value is going to be bypassing the length check. So that value is going to be bypassing the length check, so everything is going to be cool. Now what rest is that what needs to be sent for the username. So for example, in this case, we're going to be sending 32 bytes of data. Then the password is, let's try for example to send those 32 bytes of data and see if we have hit the return address or not. If so, so we can just adjust the values with the return address of the unlocked door and try to craft something that can just fit exactly with the layout of the stack, so that we can change for example the return address in this stack, and then maybe we can do something more elegant than that by just creating some few codes using Python just to create a payload that we can just open up the door with. So let's try for example to send 0x20. So let's say I'm gonna be sending 0x20. So I'm gonna be sending this amount of bytes. The first thing to do is to set the breakpoints first. So I'm gonna be setting a breakpoint after um, before exactly before reading the password, and I'm gonna be setting a breakpoint after copying the password. What else? And I'm gonna be obviously putting a breakpoint before we return, just to make sure that we have hit the right return address, which is the unlock door function. And also I'm gonna be putting a breakpoint at the address, this one, to just check if the sum of the two lengths, which is the username and the password, are okay or not. So if we continue, so we have to reset that. If we continue, I'm gonna be checking the hex encoded input. um, so let's try to see. So this is basically the username that is copied at the address 2400. Everything is cool, yeah. Everything is cool, yeah. We have those ones in front of us. Now the thing is, how much data do we need to send to the return address, which is 40 and 44, yeah, which is 4440, which is the unlocked door. It's not the unlocked door. Wait a second. It's supposed to be the next instruction after calling the login, which is this one. Where is it? Yes, it is this one. So we want to return to this one, which is 444C. So we obviously have to send 2 bytes of data, 4 bytes of data, and then the return address. So the payload should be obviously 41 multiplied by 4. Yes, and you add obviously the return address, which is 4C44. We obviously have to flip the bytes of data because he's using little Indian as usual. So basically now we have a payload that we can send. So this payload needs to be sent with the password, since now we have sent the username. So this is basically the username. So the password should be um, so the password should be the payload first. We first send the payload, and then we start overflowing the rest of the stack just to get to the length that we want to. So we basically have to send 0x11f, or is it 11f? Is it 1ff? You think 1ff, yeah. 0x1ff minus the length of the payload that we have sent at the beginning, and we divide it by 2. Why? Because simply they are in hexadecimal. So once we do that, I suppose everything should be cool. So if we open up the password, so this is basically our password. So it's first gonna be just filling the space between the return address and the username, which is this space, and then we overwrite the return address, and then we just complete it with just some random bytes just to get to the length required, which is 0x1ff. Yes, cool. I think this is pretty cool. So if we try to do that, if we reset, if we just send that, so this is the username, we hit the get string. So if we send this password, which is this one, we basically moved. So register 15 is having that value. So if we continue again, so register 15, I was having 0x 0 to 1f, which is the sum of the username, the sum of the length of the username and the length of the password, which is the required one that we have just calculated theoretically, yes. Once we do that, we just can now continue. So we hit now the end of the stack frame, so he's gonna be cleaning up the stack. So if you just take a look at the memory, so he's basically now here. So he's gonna be doing a simple step. So this is basically the value. He needs to get back the value that he had pushed, which is the register 15. If we step, so basically this is the return address. Now if we continue, we just have unlocked the door. So now if you try to solve that on the server, we try to send, for example, this username and this password. We just unlock the door. Yes, I think this is an interesting challenge as the Santec Cruz challenge. I really enjoyed it. I hope you learned something new. Yes, so don't forget to follow me on Twitter again. Don't forget to subscribe. We are almost there. I think in a matter of days we're gonna be finishing all the micro corruption challenges. And yes, so have a nice day. Bye.